In example 19.6, we want to graph another logarithmic function. This function is given to us as g, with g of x equaling log base 1/2 of x. So because of that base value being 1/2, we have a base value that is less than 1. This is going to be expected to be a logarithmic decay function. So going back and making a table, in the same way that we did with example 19.5, I'm going to write g of x as y equals log base 1/2 of x. So if I rewrite that in its equivalent exponential form, I would have 1/2 raised to the y is equal to x. And that's going to be the version of this equation that's going to be easiest to be able to make an equation with. So we'll have x and then y, where y represents g of x, and we'll select y values. I'm going to use -2 through 2 integers. And as I substitute in these y values into the 1/2 raised to the y equals x equation, I should get the following results. I will end up with +4 for x, +2, then +1, then 1/2, followed by 1/4. So let's plot those points. 4, -2, 2, -1, 1, 0, 1/2, 1, and then 1/4, 2. So we're going to get another logarithmic curve out of this, but this time the logarithmic curve is going to show a decrease going from left to right. This is going to be the graph of g, and there is still a vertical asymptote located at x equals 0, and that explains why the domain, again, is only from 0 to infinity. The domain for g will be 0 to infinity. The range of g is going to be all real numbers, and the only asymptote is a vertical asymptote located at x equals 0. So again, because our base value is less than 1, we expect that to be a decay type function, and so for logarithmic decay, we see the decrease going from left to right.